CLO for this lesson is that students will be able to describe in writing data using standard deviation as well as the following language: if-then statements, average, and standard deviation. So in your own words, what do you think you're going to learn how to do in this lesson? All right, so let's just start with the notes and our vocabulary words, which is average and standard deviation. So the word average is one of the measures of central tendencies that we've already learned. It is just another word for mean. And to figure out the mean or the average, remember you add up all of your data points, then divide by how many data points there are. And what this does is tell you what's going on with the data on average. However, that's not the only way we can describe data. Another way is called standard deviation. So the word standard means what's the standard, what's the norm, what's like typical. And the word deviation means to be different from. So like if you're going down a road and you deviate from the path, it means that you're taking a different route, you're changing. So this means the normal change. Another way to say it is how normal it is to be different than average. So wait, what? Let's talk about what this is trying to say. So just because there's an average, for example, let's say we do a survey that asks how many cups of soda people drink a day. They might say the mean, the average is 3 cups. So on average, people have 3 cups a day. However, most people aren't going to say 3 cups a day. Some might. Just because it's the average, though, doesn't mean most people are going to say 3. But people are going to be sort of close to 3 because that's the thing, that's the average. So standard deviation tells you how normal it is to be different than that average. So if 3 is the average, but the standard deviation is 1 cup, that means for most people, they drink between. So if the average is at 3, but it's normal to be different from that by 1 cup. If I take that 3 on average and minus the 1 cup, I'd get 2. And if I take the 3 and add the 1 cup, I get 4. Because being 1 cup away, you can either be 1 cup under the average or 1 cup over the average and still be different by 1 cup from average. So again, standard means the normal difference for deviation, the normal difference from the average. And if the normal distance is 1 from the average, you take your average or mean and you subtract your standard deviation and you add it to figure out that most people drink between 2 and 4 cups of soda a day. Because again, averages are just averages. They are not what most people said. It's just what the average is. So most people are usually going to respond somewhere really close to the average. And that distance that people usually respond within is called the standard deviation. So this process right here to figure out my little range, my standard deviation range, this 3 was the average or the mean. And then I had to subtract away this 1 was my standard deviation. I'm going to just write SD for standard deviation. And this gave us the bottom end of the range. Versus when you took your average or your mean, and then you add your standard deviation, you end up with the top end of the range. So let's do another example. Let's say on average, the data said that. So let's do another example. It says a survey asks how many hours people sleep at night. The mean, or on average, was 6 hours. However, the standard deviation is 1.5 hours. So if I take my 6 and I subtract my standard deviation, I get 4.5. Then if I take my average and I add my standard deviation, I'd get 7.5, which means that while on average people slept for 6 hours last night, most people slept between 4.5 and 7.5 hours last night. Let's do one more example. So this says a survey asks people what they thought the perfect age to get married is. And the average, the mean, is 25 years old with a standard deviation of 7. So I'm going to take the 25 on average and subtract 7 years. That would give me 18 years old. I'm going to take the 25 and I'm going to add the 7 years to that. And that's going to give me 32. Which means the meaning of my results, once I figure out the mean and the standard deviation, what it means is that most people think the perfect age to get married is between 18 and 32 years old. So we started with trying to understand if you had already calculated the mean and you already calculated the standard deviation. What does that mean in terms of the data? And basically what it means is if I have a survey and I say, so what do you think the perfect age to get married is? There might be this number line where I'm charting my results. And this might be 0 years old, and this might be 100 years old. And there's tons of data in between here that people responded with. So if this is 50, make this right here 25. So I'm going to only break my number line apart for the earlier numbers because I doubt anyone's going to say they think the perfect age to get married is above 50 years old. Maybe one person might. Heck, maybe even another person might. But for the most part, people are going to say somewhere down here. I doubt anyone's going to say before 15. But, there are some traditionalists that might think younger is better. So I'm going to put one right there. But if it's saying on average, most people are saying 25, I'm sure there's one person at 25, maybe even two. But most of them are going to be right around 25 of what people think is the best age to get married. So let's say these are all my data points of what people think is a great age to get married at. And I do the math and I figure out that 25 is my average, my mean. So if I look up where my mean is, it might hit 3 data points, but of all these dots, most people did not say 25. It just happened to average out to 25. However, after figuring out my standard deviation, where I subtract my standard deviation to figure out that my standard deviation at 7 subtracts down to 18, which would be about here. And then I also have to add my standard deviation. And when I added my standard deviation to my average, I got 32 years old, which is about right here. And then what they're saying is that most people responded between here and here. which look, most of the dots are in this little range. And so this is what standard deviation means. Now, how do we figure it out? Honestly, figuring out standard deviation by hand is a very, very long process, and it's really hard. So we're going to do it for a little bit of data. This data says a survey asks how much money people currently have in their savings account. The data is below. So someone said $500, someone said 0, someone said 800, someone said 1,000, and someone said 600. So only 1, 2, 3, 4, 5 people responded to this survey. So step 1 is you have to calculate your mean, your average. And to figure out your average, what you do is you add up all of your data points, and then you divide by how many you have. Basically, what we're doing mathematically is we're taking all of their money, his 500, her 0, his 800, their 1,000, or 600. Taking it all, and we're adding it all up, and we're putting it into the same pot. Then we're going to divide it up equally amongst the 5 people that we're talking about. Because what that does is it figures out if we were to combine all of our money together and make it equal across the board, what would we have on average? Which means this person with a 0 will have more money, and this person with 1,000 will end up with less because you're averaging it out to be the same for everybody. So if we did that, we added up all these 500 plus 0 plus 800 plus 1,000 plus 600 is going to be 2,900. It's getting divided up amongst 5 people. To say on average, they each get $580. That's their average, that's the mean. So the next step to figure out standard deviation, because this is all about 5 steps to figure out standard deviation. So once you know the mean, you have to take every data point. So I had 500 and 0 and 800 and 1,000 and 600. So these are my data points. I have to subtract the mean from each data point. So this 580 that I calculated up here for my average, I'm going to subtract that away from each one of my data points. So using my calculator, 500 minus 580 is negative 80. This one's going to be negative 580. This one is going to be 220. This one is going to be 420. And this one is going to be 20. So that's step 2. Step 3 is to take each one of these answers and square it, because it says square each answer from step 2. So I had negative 80, negative 580, 220, 420, and just 20. And the last one. We get the square each answer. So in order to square something, I'm going to take the number like negative 80 and press this x squared, and it gives me 6,400. It's 580 being negative, but squared is 336,400. $220 squared is 48,400. 420 squared, 176,400, and 20 squared is 20 times 20, which is 400. So that's step 3 in standard deviation. Step 4 is to now find the new mean of all of the new numbers from step 3. So I'm going to take all 5 of these and add them all up. Equals 568,000. Then I have to divide it by 5 because there were 5 data points, because I'm finding the mean of these new numbers. And remember, to find the mean or the average, you add them up and divide by how many there are. And so it's 113,600. And step 5 is I take this answer and I square root it. And so in the calculator, I just hit the square root button and it tells me the standard deviation is $337.04. And this is the standard deviation. It was a lot of work. Particularly, I only had 5 pieces of data. Most studies, it's not even a good study unless you have 30 pieces of data. So this is very, very stressful and a lot of work. There's a quicker way to do it. I'm never going to make you do it by hand. So if you felt a little confused by the steps, it's okay, because I'm not going to make you do it by hand. The point is this is how you do it. This is the steps to figure it out. But once you know the standard deviation, what matters is you understand what it means. So its meaning, what it means is, remember, you have to take your average, and all the way from the top, our average was 580. And I have to subtract my standard deviation to figure out the lower end of my range. Which is 242.96. And then I have to take my average and add that standard deviation. So get the upper range of 917.04. What this means is that most people in the study have between $242.96 and $917.04 in their savings account. And that's the meaning after you know the standard deviation. So the fast way to do it, thankfully, is that we can always use the internet, and there's a fast way to figure it out in a Google Sheet. And all you have to do is you type in enters and ST for standard, and then DEV for deviation. So it's STDev to say calculate my standard deviation, and then you remember you have to highlight your data and then press enter. So showing you a quick example. So it says the teacher records how many times each student participates in class that day. The data is below. So we don't know who, but one student participated 9 times. There's a different student that participated 8 times, one who did 11 times, one who did it no times at all. So this is all the data, and figuring out standard deviation by hand would be a long process. Even figuring out the average by hand would be a long process to add these all up and divide by the 25 points of data here. So in the computer, the easy way to figure out the mean is the equals average. And I can just click on it here because it says average. But then I need to highlight my data. So click and I pull down until all my numbers, and then I can let go and press enter. And then look, it figured out the mean for me. The average was 7.08. And then I could do the same thing for standard deviation by pressing equals stdev. See how it says stdevs for standard deviation? But again, you have to grab all of your data points and then press enter. The standard deviation is 3.78, which means if I do my low end, I could just do equal, press my mean box, and then minus, and then press my standard deviation box. And if I press enter, it does the math for me. I could also do the upper range by doing equals, click on the average, and then plus my standard deviation box. And that's the upper range. Meaning, because the situation was about how many times each student participates, is that most students participated between, and here's the thing, you cannot tell me that they participated 3.29 times. That's not possible. So I would round down because 0.229 cents is closer to having no money than it is closer to having $1. So I would round this down to 3 times. And 5.86 cents is closer to the dollar, so I'd round it up to 11. So most students participated between 3 and 11 times in class today. And if you look, most of these are between 3 and 11. 9 is in between 3 and 11, so is 8, so is 11. 0 is not. The 6 is, 4 is, 7, 7, 7, 8, 9, 10. 2 is not between 3 and 11. So this is someone else who's not in the standard deviation normal range. 12 is too many. 11, 6, 7, 9. 12 is too many. 11, 8. 1 and 0 is a bit lower. And then here's 1. So most of these, there were a couple that weren't in this most people range. However, most people were. These red ones are not outliers. Outliers are very, very different. There's a lot of different math to figure out if something's an outlier. This is just meaning it's not most people. They're not a part of most people who are in this study. But they're not outliers either. They're just not in the standard deviation of 1 away. And that's it. So using if-then statements, like if I have a set of data, then I can figure out the standard deviation by and explain what you learned how to do in class today using the words average and standard deviation as well.